Hi everyone, welcome back to the section 4.1 video. In this video, we're gonna get to our homogeneous general solution and define what this actually would be with our building blocks of linear dependence, set of solutions, etc. So a set of linearly independent solutions of a homogeneous linear differential equation is given a special name. And it's given a special name of fundamental set of solutions. So any set of solutions, y1, y2, all the way up to yn of linearly independent solutions is said to be a fundamental set of solutions. And so we've been working our way up to this general solution for homogeneous differential equations. So a fundamental set of solutions, linearly independent solutions, is a building block for a general solution of a homogeneous differential equation. So general solution, this is a term we've been saying throughout this lesson. So let's go ahead and see what a general solution actually is. So let y1, y2, all up to yn be a fundamental set of solutions of the homogeneous linear nth order differential equation. Then the general solution of the equation is just y equals C1 times that first solution plus C2 times that second solution, all the way up to how many solutions you might have for the type of order the differential equation is. If you're in the second order, you're going to have two solutions. But yeah, just the C's are just constants. Okay. So, linearly independent solutions lead to fundamental set of solutions, which provides for us a general solution. Let's write that down. Linear independent solutions leads to fundamental set of solutions, which leads to a general solution. Okay, great. So let's look at a general solution, or excuse me, a set of solutions, and we're going to verify that the functions form a fundamental set of solutions and then form the general solution. So this is, step one, and then step two is forming that general solution. Okay, so how do we form a fundamental set of solutions? What do we need to do there? Well, what we need to do there is test for linear independence. Okay, so that's what we need to test for. So we have a differential equation here, y double prime, and we have two solutions, y1 equals e to 3x, y2 equals e to negative 3x. So let's see if we can form this general solution. So here I'll say solution to get going on this. And, let us verify that y1 and y2 are a fundamental set of solutions. So what we need to do is test for linear independence. We're going to use the Wronskian. So the Wronskian is e to the 3x, e to the negative 3x. We're going to set up the determinant e to the 3x, e to the negative 3x. Derivative of e to 3x, 3e to 3x. Be careful with that chain rule. And Same thing for the e to the negative 3x. Just be careful with the negative with the chain rule. So we are going to cross multiply. It's a determinant and subtract the products. So we get e to the 3x times negative 3 to the negative 3x minus e to the negative 3x times 3e to the 3x. And so interesting thing happens here is that we have 3x and negative 3x. Well, when we multiply, the exponents add to each other. So what this ends up being is just negative 3e to the 0. And likewise, for our other expression, this just becomes minus 3e to the 0 as well. And this works out nicely. E to the 0 is just 1, so we have 3 minus 3. That equals negative 6, which we get negative 6, which never equals 0. So y1 and y2 are linearly independent sets. And so are a fundamental set of solutions. Great. Therefore, my general solution is going to be the combination of these two solutions. Don't forget the constant though, but it'll be C1, y1 plus C2, y2. And so y1 is just e to the 3x plus C2, e to the negative 3x. And so that's my general solution of my fundamental set of solutions because we verified that they're linearly independent. Okay, so that's how we verify if solutions can form a general solution to a homogeneous differential equation. So homogeneous differential equation. Okay, so that's a good example for verifying and seeing. So that's it for this video. Thank you for watching, and I'll see you in the next one.